Today we're going to talk about how to solve linear systems by using the substitution method. So I'm going to look at these two equations. I've got 3x minus 5y equals negative 8 and x plus 2y equals 1 in my system. If I'm going to use the substitution method, the first thing I want to do is look at my system and pick an equation that would be easy to work for and look for a variable that has a coefficient of 1 or negative 1, and that would be the variable that I'm going to solve for. So when I look at this system, the obvious choice is going to be this equation right here. I'm going to work with this one first, and I'm going to solve for x, since x has a coefficient of 1. So I'm going to go off to the side, and I'm going to write x plus 2y equals 1, and I'm going to solve it for x. Now, a lot of times we get in the habit of always solving for y, but that's not what we necessarily need to do. Occasionally we need to solve for x. So always look for that variable with a coefficient of 1 or negative 1, and that's where you're going to start when you use the substitution method. So when I take that equation and I solve it for x, I get x equals 1 minus 2y. After I solve it for a variable, I'm going to take that expression and I'm going to plug it in to the other equation. You must go to the other equation. You cannot go back to the same equation. If you go back to the same equation, everything's going to cancel and you're going to get really confused. So you have to go to the other equation. So now I have 3, and I know what x is. X is 1 minus 2y, so I write 1 minus 2y minus 5y equals negative 8. So now I have an equation with just y's in it, and I can solve it for y. So the next step will be to distribute the 3. So I have 3 minus 3 times 2 is 6, so minus 6y minus 5y equals a negative 8. And then I'm just going to collect my like terms. A minus 6y and a minus 5y would be a minus 11, so I have 3 minus 11y equals a negative 8. And then I'm going to want to subtract 3 from both sides and get a negative 11y equals a negative 11. Oops. And then when I divide through by negative 11, I get y equals 1. So now I know half my answer. One of my solutions is going to be y equals 1. Once you figure this out, I go back to either one of these equations. It really doesn't matter which equation I go to. At this point, again, I would pick something that's easy to work with. So probably the second one again. I would pick up this. I'm going to plug this in here and see what happens. So now I've got x plus 2 times y, and this time I know what y is. Y is 1, so 2 times 1 equals 1, and I solve it for x. So I have x plus 2 is 1, and then I subtract 2 from both sides. Oops, let me erase that. And I get x is, let's see what I get. I get x is, when I subtract 2, 1 minus 2 would be a negative 1. So now I know what x is. I know what x is. I know what y is. And I'm going to write my answer as an ordered pair. So I'm going to have the ordered pair negative 1, comma 1, and that's going to be my solution. So that means when I graph these two lines, they're going to intersect at the point negative 1, 1, and I have an independent system. Now, you can check your answer, and I would encourage you to do so in your head. I could pick up a negative 1, drop it in for x here, so I get negative 3 minus, if y is 1, 5, and so a negative 3 minus 5 is a negative 8, so it checks in the first equation. I'll plug in a negative 1 here. I get negative 1 plus 2 times 1 is 2, so negative 1 plus 2 is 1, so that checks. Remember, the solution has to satisfy all the equations in your system, and this does, so I know that I have found the correct solution. So let's go ahead and look at one more example. Here I've got 5x minus y equals 16 and 2x plus 3y equals 3. Now I look at this system and I'm looking for the equation that has the variable with a coefficient of 1 or negative 1, and I notice in this case I've got the first equation that meets that criteria. Here, instead of solving for x first, I'm going to want to solve for y. If I solve for y first, I'm going to avoid any fractions or any difficulties you might encounter. So we're going to take this first equation and solve for the y. Sometimes we solve for x and sometimes we solve for y. Again, you're just looking for the easiest variable to solve for, and typically you're looking for a coefficient of 1 or negative 1. So here, if I solve this for y, I'm going to subtract 5x from both sides, so negative y equals a negative 5x plus 16 And I want to solve it for y. I don't want to solve it for negative y, so I need to go ahead and multiply across by negative 1. So I get a positive 5x minus 16. Okay, so that gives me my expression. So I'm going to take that expression. I'm going to go to the other equation. I don't go back to the first equation that I used. I go to the second one and change that y to 5x minus 16. So now I have 2x plus 3. Now I know what y is. Y is the expression 5x minus 16. So 5x minus 16. And it equals 3. And then I'm going to solve this because now I have an expression, or an equation, all in terms of x. So I take my 2x, I'm going to take my 3, and I'm going to distribute it. And 3 times 5 is 15, so I get 15x. And 3 times a negative 16 is a negative 48. Equals 3. I can add my like terms together. 2x plus 15x is 17x. Minus 48 equals 3. And then I'm going to add 48 to both sides, and so 17x equals 51. Make that look more like an x than a y. So now x is going to be 3. 51 divided by 17 is 3. So I know what x is. So x is 3. Then I'm going to take my 3, and I'm going to go and I'm going to plug it in to either one of these equations. Does not matter which one, and I just might as well. I'm going to go back to the second one. Why not? I'll just go here. So I'm going to do 2 times 3, because x now is 3, plus 3y is 3. And 2 times 3 is 6, so I get 6 plus 3y is 3. And then I can subtract 6 from both sides. So 3y equals a negative 3, because 3 minus 6 is negative 3. And y would be a negative 3 divided by a positive 3 would be a negative 1. So now I know my solution. My solution is going to be x is 3, so I put the x first. And the y is negative 1. So I get the point 3, negative 1, and that's going to be my solution. Now you do want to check it real fast. So 3 times 5 is 15, and 15 minus a minus 1 is a plus, so 15 plus 1 is 16. And I need to make sure it makes the second one true as well. So 2 times 3 is 6, and then 3 times a negative 1 is a minus 3, so 6 minus 3 is 3, so it works. So the 3, negative 1 satisfies both these equations, and it would be a solution to my system. Let's go ahead and take a look at one more problem. The reason being is, for some reason, students sometimes have trouble with problems like this. So I want to look at this system. I've got 2y equals negative 4x, and 2x plus 2y equals negative 4. And you should notice something right away. First off, when I look at my equations, it looks like everything has a common factor, and it does. So what you could do before you do anything is take your system and simplify it. You see how this is divisible by 2 and the negative 4 is divisible by 2? Go ahead and you can divide 2 across that equation. So now I have y equals negative 2x. Okay? This is just a simplified version of the original equation, and you can do that. So 2y divided by 2 is just y, and negative 4x divided by 2 is negative 2x. And look down here at this one, I've got 2x plus 2y equals negative 4. Well, there's 2, 2, and 2. It's a common factor, so why don't I go ahead and divide everything through by 2, and I end up with x plus y equals negative 2. So I've created an equivalent system to the original system. I've just created a simplified version, and sometimes when you're solving these systems, it's a good idea to do that. If you see something you can divide through an equation, go ahead and divide it through and make it simpler. So I'll look at this. If I want to use substitution to solve it, and I look at my two equations, I could really start anywhere, but it would kind of make sense to start with this first one. It's already solved for y. So if it's already solved for y is negative 2x, I can go ahead and take the negative 2x and plug it in for y here. So I have x, y is negative 2x, equals negative 2, and x minus 2x is a minus x, equals a negative 2. And remember, I'm solving for x, not negative x. So I'll multiply across by negative 1 or divide by negative 1. I get x is 2. So there's my x. Now I have to figure out what y is, so I can go back to either one of these two equations here, or even back over here, but I'm going to choose to go to one of these. I think I may just go to this first one and plug in a 2 here for x. So I've got y equals -2. I know what x is. It's 2. And then I know that y would be -2 times 2 is -4. So now I know what my solution is. My solution is going to be the point 2, -4. And again, you want to check it real fast in your head. 2 times -4 is a -8. Over here, -4 times 2 is a -8, so it checks the first one. 2 times 2 is 4, plus 4 times a -4 is -8. So I've got 4 minus 8 is -4. So it satisfies all the equations in the system, so it would be a solution. So we've gone over how to solve by substitution a linear system with 2 variables. So go back, look it over, study it, and come to class and see if you have any questions. I will see you in class.